Hi, in this video I'm going to discuss about a very popular machine learning algorithm known as the nearest neighbor machine learning algorithm. It is a classification algorithm. It can also be used for regression problem, but we will see only the classification aspect of nearest neighbor algorithm. So we call that as nearest neighbor classifiers. So what's the basic idea behind the nearest neighbor classifier? Well, it goes like that. If it walks like a duck, then it is probably a duck. That means uh, here is the picture and the code goes like this. The picture is that we have been given a picture and it looks like a duck, but we do not actually know whether it is actually a duck or not. So this is a training set. We have got different birds, and we'll just have to match what is the closest this picture is with the given pictures. Okay, and so all we need to do here is to measure the distance. Okay, how close this picture is with another picture. The closest the picture is, the more likely or the more probable the picture is similar to a given picture. So this is our training set. Okay, so this is a given training set, and all we need to do is compute distance, and you will find that one that has least distance in terms of the behavior of this picture, or the behavior of the attributes of it, this bird, we will match that to this given one. So this is a test record, and we are trying to match it to one record from the training one. So that's exactly what we'll see in a nearest neighbor method of classifying a data point. So here is another example. So they have got different circles, and the circles are marked in two different colors, and we have a test set. So this test one is in the black, with this black circle. So we need to know, and this is a totally new one. Is it which color is it? Is it of this one or this one? Okay, there are two different colors. So how do we get to know? So we get to know using nearest neighbor method. So we take a majority vote. So majority vote within k nearest neighbors. So we take k nearest neighbor. K could be anything. It could be 1, 2, 3, or it could be even more than 3. So we'll take the k nearest neighbor to this test or the new circle, and we'll take a majority count. Okay, so if you take these three, and we suppose these three are the closest circle to this the new circle, which is the black one, and k here is 3. So what is the majority? Well, the majority is that we have got two we have got okay 3 grain. Okay, maybe it is considering another one. Maybe we can consider this one. Okay, if k is 4, we have got 3 greens and just 1 brown. That means the new circle is just a green circle, right? If k is 3, we have got this one and this one, two circles which are green, and just one which is brown. So the majority is that it is a green. Hence we conclude that it is a green circle. So the new circle, or the given one, is a green. So formula to find it out is calculate the mean, and k could be any number, and we'll see how to choose the best k, or the optimal k. K could be anything, by the way. It could start from 1 to n could be of any number. So it's not good to take just very small k or very large k. So we'll see what is the optimal k. So the estimated value of x is the new one, is given by, just take y's means give a subset of the training set, take the majority count, the one that is is major or is appearing maximum times in your given subset, is the one to be chosen for the new data, or the new or the unknown data. Okay, so unknown data is just the test data for it. All right, so this is the unknown record, and you will have, not just one unknown record, it could have many. So it requires three things: a set of stored records, which is your training set. Of course, technically speaking, it's a training set. Distance matrix to compute distance between records. So we should be able to compute the distance between what, between you given a new data, the new data point. This is the new data point, that's what we have marked it in red, and the corresponding near values, right? Near values. Okay. Alright, and the third thing is the value of k, the number of nearest neighbors to retrieve. That means you also need to know what exactly should be the value of k. It should be 3, 4. So that is another important thing that one should find it out, and we'll see how do we come up with an optimal k. So to classify an unknown record, we need to compute the distance to the other training records. So we just compute the distance using some sort of a distance formula. It could be a Euclid formula or some other formula. Identify k nearest neighbor, which is of course very important. Use class levels of nearest neighbors to determine the class levels of unknown record. In case it is a classification problem, of course, we need to take the maximum count. If it is a regression problem, we just need to take the average of the maximum counts. Okay, so that's essentially a difference between using a nearest neighbor for classification and for regression. So for classification, take the maximum of the number of data points of a particular category within that nearest neighbor subset. So here in this case, when you take the circle, we see that there is only plus signs. There is no minus sign, right? It's only plus. It's only positive signs. There is no negative. Hence, the new data point is nothing but a plus. Okay. So if you take some data point here, and let's say k equal to 4, and take the nearest neighbor over here, you will find the data point is closer to the negative signs, right? And that's a negative. That's what we conclude. So the estimation is very simple. It's just very crude way of, so to say, computing or classifying a new data with a given training data. Okay, so there could be several numbers that can be associated with k. It can be 1, 2, 3 or more. So here is an example of just k equal to 1. Okay, this is a given, this is a new data, and the given data is just negative and positive, and we just taken the most closest one, or the first one, which is the most closest one, and it's negative 1. Now we conclude that x is negative. Now just take 2. You cannot conclude because there is just one negative and one positive. Okay. Now you take 3, k equal to 3. We've got 2 positives and just 1 negative. That means it turns out that x is positive. So when k equal to 1, we concluded that x is negative, whereas when k equal to 3, we concluded that x is positive. Now that's a very drawback of using a nearest neighbor, that if you change k, your answer actually is changing. So what is the most appropriate k that you should take? So the idea is that you should take a number that gives you the best possible answer, and getting that threshold value is the key. So what you need to do here is that compute distance between 2 points. How do you compute distance between 2 points? Well, if you are familiar with your high school algebra, computing distance between 2 points with in a plane x1 y1, let's say this is x2 y2, is nothing but x2 minus x1 square plus y2 minus y1 square, and then just square root of that. So if pi is a data point, qi is another data point, just take the difference. Difference could be the coordinates, or just any number. It could be any quantity, a length, breadth, height, weight, or anything, any measurable quantity. Take the summation of that, square of the summation, and take the square root, and you find the distance. Determine the class from the nearest neighbor list. So this is a way to find out the distance. Okay, and once you have the distance of each point, so let's say this is your training point. Okay, and we have, let's say, circles and then pluses. Okay, now we have it. We do not know what this point is, whether it's a circle or is a plus. So we calculate distance from each point just to know what is the nearest one, and then we take the majority count and find out whether it's a circle or a plus. So first is finding the distance, and how do you find it? Using Euclidean distance formula. So in the next step, take the majority vote. Okay, just take, let's say, k equal to 3 or 4. So within that subset, what is the majority? It's a circle or it's a plus. Based on that, take the majority vote. The one that is of majority is the one that would be associated with the new data point. All right, you can also weighting. Okay, you can also do a weighting without giving equal weight to each data point. You can also take the weight. So the weight factor, the weighting that you could actually take, is inversely proportional to the distance from the new data, and that's given by 1 by d square, where d is your distance, and that makes sense, right? The data point that is closest to the new data should be given more weight. Like in the previous example, here there are three training data points, right? There's a minus, this one, and this one, but this negative has a greater weight, or should have a greater weight, right, than these two positives, because they are farther from the data point x. So that's a better way of calculating a majority count. So how do you choose the value of k? So choosing the value of k is the key. If you choose the value of k to be very small, it is very sensitive to noise. Okay, because very unlikely you will get a very general view of something if you take just few data points. In any statistical estimation, you must be knowing that the number of observation, if it is less or it's very small, then you probably won't arrive at a very correct result. Okay, hence it is always preferred that you have more number of data points, or more number of training data points in the training samples. Similarly, if you have just two, similarly, in nearest neighbor as well, you should not have k to be very small. That's bad, and it's very sensitive to noise or outliers. If k is too large, the neighbor may include points from other classes. Okay, because if you take just too many outside points which are not at all related to your given data or the new data, it could include something totally unrelated, and that could bias the result. So the idea is to find an optimum, and you can try with multiple case that say for instance you are not very sure, start with 2, 3, 4, 5, and then you have a given test data, right? Not just one test data, I could have several of them. Do repeatedly with different k's, try out what number of k or what value of k is giving you the maximum accuracy in the test data. Okay, so what value of k is giving you the best accuracy? Okay, you try with 2, try with 3, try with 4, 5, whatever number of ways, because computational power has increased for computers, so you can just try out a number of values of k and run the algorithm that at what number of k your tests, the accuracy level in your test data is maximum. Just choose that k as your optimal k value. The one issue that you would be facing while building a KNN algorithm is a scaling issue, because you would be using different attributes, and attributes would be in different scales, or so attributes may have to be scaled to prevent distance measures from being dominated by one of the attributes. If you take the nominal numbers without taking into consideration, or without just without taking into consideration the different scales, you'll be in trouble. Let's see this example. Here is a height which varies from 1.5 meter to 1.8 meters. That's in one unit. Weight is there in 90 lb to 300 lb. That's in another unit. And the income is from 10,000 to a million. So the numbers are different. Okay. So given the numbers are different, you will have a problem when you do not sort of normalize them or standardize them and use that in your prediction. That would give you some sort of dominance by one or a couple of attributes, and some of these attributes will not have any impact in your model or in estimation, and that would be a problem. So it is always good to sort of standardize and normalize. Another problem that you would be facing is the problem with Euclidean measure. If you do an Euclidean way of measuring the distance, you could have a problem, and that could possibly give you counterintuitive results. So here is this example. You have got two sets of data points. So this is binary data, this is another binary data. This is one binary data, and there's two sets of each pair of data sets. The distance, if you measure the distance in Euclidean distance for this pair, first pair, you get it's 1.142. If you measure for the second pair, you would get exactly the same value. But look at the distribution of data. In these two, in this pair, in the left one side, you see most of the data points are ones instead of 0, right? So when you match this to a new data point, you would conclude that the data point would be a 1, because the majority count is 1. Whereas here you would assume, or you would conclude that the data point would be 0, because the majority vote is 0. So the distance is same in both the sets, both the pairs, but the answer comes out to be different. So the answer could become counterintuitive sometimes. So using Euclidean distance is could be a problem in many areas. So what is the solution? The solution is to normalize the vector to unit length. Ensure that the length of the vector, the vector that you are measuring the distance, should be unit length. Okay, so when you normalize data, it will always be unit, right? It lies between 0 and 1, so it should be unit length. Alright, so that's pretty much about what is KNN classifier. You can compare your result with other classifier like logistic classifier, with the support vector machines, with decision tree, and so on. This is not a very parametric way of estimating a model. This is more of just counting or just calculating distance, which is very deterministic rather, right? So you're not estimating parameters here. It's a non-parametric way of calculating things. So one of the good thing with non-parametric way is that it is easy to do, but it takes high computational power. Okay. Whereas the parametric ways of doing like logistic regression is better in some sense, we could, it is, uh, it is something that can be understood well, and there are other aspects. For instance, finding out relationship between variable is something that you can find in logistic regression, not in KNN. So that's another difference between this parametric and non-parametric way of classifying your data. So that's about the k nearest neighbor classification algorithm. If you find this session very useful, please subscribe to our channels, and we'll be uploading more videos on various machine learning algorithms. Thanks. In this video, machine learning, big data techniques, and so on. Okay, let's get started. So what shall we learn in this session? We're going to learn what is decision tree. So I'll give you a brief explanation or a simple explanation of what decision tree is all about. We'll also learn what is theory behind decision tree, how is a decision tree built from scratch, and what's the logic, what's the algorithm used in order to build a decision tree. The applications of decision tree, it is applied in many different practical purposes. There are many different areas in which decision tree is being used, so we'll discuss few of them. And what are the issues that you might face while building a decision tree, and how you should be careful about these issues and take necessary precautions while building decision tree. So we'll discuss that. So we'll go one by one, and we'll ensure that we give sufficient time for each one of these four areas. So let's start with a simple example. Well, this is a programming task that is given to you. You have got different types of spots here. One is the circular, the other one is the stars, and they have been colored in different way. So your task is how you should differentiate the two types of spots on this particular diagram. Now it is indeed difficult to write a program that will do the differentiation or the classification. Okay, so the key word here is classification. So how do you classify these two types of spots? Well, one way could be write a program which will take care of this, but then the same program cannot be used for a totally new type of distribution of these two spots. So if there is a new classification, then you would not be able to classify using the same program. So you might have to write a new program again. And if there are hundreds of such such distributions thrown at you or given to you, you have to write 100 such programs, and that is difficult, and the numbers could go even more, because the moment you have a new distribution, you have to write a new program. So that's a very inefficient way of going, and that's where decision tree comes into picture, and it's going to help us automating the entire thing, automating the entire process just by writing the code for once, and it will take care of all the new scenarios that you will be facing or you will be given. Yes. So let's define decision tree like this. So as I have already said, decision tree is a classification technique. So the word to be given due importance is classification. That means if there are two categories of things, then it is able to classify into that. Okay, this is one category, this is another category. So decision tree is used to classify the data, classify data into two or more categories. Okay, so remember, there could be two cases, there could be more number of cases as well. Okay, so given the collection of record, we call that as training set. That means the data that is given to us. So we have been given a training set, and each record contains a set of attributes. Okay, so each classification has to be associated with some a few number of attributes, and the attributes um, the attributes is associated some sort of a class, and we'll take an example to understand what it means. Now the idea is to find a model for class attribute as a function of the value of other attributes. Okay, so we can take example of a credit card fraud. How do you know that a certain transaction in credit card is a fraud or not? Okay, fraud could be yes or no, right? And there are many attributes which would be like the amount of transaction, okay, the time of transaction, the location of transaction, okay, gender, who has done it, that could be another factor. So these are the attributes using which we'll know whether the fraud is going to happen or not. So given this data, fraud data, we need to find a function that relates the both the things. Okay, so we should be able to write function like this: fraud yes no is a function of amount of transaction, time, or the at timestamp when the transaction happened, and from where it happened, location. So if we are able to find such a function, we should be able to find out if a particular new transaction is going to be a fraud or not, given the amount, time, and location. So all we need from decision tree is to find that function. And you hope you understand what a function is. Function is nothing but, let's say y is equal to 2 plus 5x. So that's a function. So given x, you will always find y, right? So that's a functional relationship between x and y. So we just want that kind of relationship between variables, and that's exactly what is done by decision tree. So here is an illustration of classification of tasks. So we have got 3 attributes and 1 class, and you of course always have 1 class most of the times. So the class is yes or no. You can see we have got yes and no, and based on certain attributes. So we've got 3 attributes: attribute 1, which is yes and no again; attribute 2, large, medium, small, so that's another classification; attribute 3 is some numbers, some continuous numbers. So based on these 3 attributes, we need to know whether the class is yes or no. Now this we call it as a training data. Okay, training data. Why? Because we will use this data to find the function, function that will relate the class with the attributes. Okay, so we call that as a training data. So in training data, you will always have the class already defined, but in the new data or in the test data, you won't have the class. You need to find using the function. So this data, training data, will be used to find the function, and then the function will be used to find the class, the value of the class variable, this class, this particular thing, for a new data, completely new. That's the idea. So we use this for finding a model or a function. So model and function are basically same, at least in this scenario. So to find out such a function or such a model, we call that as training a model. Okay, training a model or using a learning algorithm. So what is a learning algorithm? It is a type of algorithm which uses training data to find the relationship between a class and its attributes. Okay, and decision tree is one of these learning algorithms. There are several of them. You might have heard about other learning algorithms, but decision tree is just one of them. Okay, so you use a learning algorithm to come up with a model, and you apply that model to find the class using the attributes. So you have this model in place. Now you have attribute 1, attribute 2, and attribute 3, And using this three information, you find out whether class is yes or no. That's not given to you. Okay, in training data that is given to you, but in test data or new data it's not given. You should be able to find that using your model or using the functional relationship between the class and the attributes in the training data. Alright, so that's the idea behind decision tree. So we just understood in a nutshell as to what decision tree is all about and how we can use it to sort of classify data into groups. So there are examples, some real life examples of classifying data using decision trees. And in our world, when we're dealing with the data on internet, we very often use classification algorithms without our notice, though we do not actually quite know that there is a classification algorithm like your decision tree is being run in behind, but for getting us informations, but we don't quite realize it. Okay, so there are pretty much everywhere that's being used. So it's used in medical research where predicting tumor cells as benign or malignant. So find out whether it's a good cancer or it's a bad cancer. You use classification algorithms. You use classification algorithms to credit transactions to find the legitimacy of a transaction, whether it's a fraudulent transaction or it's a normal one. You use that to classify secondary structure of protein into different types. So that's used in biological research or research in medical sciences. You use that to categorize news story. So Google does the news story categorization as finance, weather, entertainment, sports, etc. So Google uses data from different news sites and categorize them into finance, sports, entertainment, and so on. You also, the famous use of a decision tree algorithm is to classifying your emails into spam and inbox email, right? So your spam email goes to spam folder, and the normal or the good emails or the useful ones go to the inbox, right? So how does that classification happen? And that happens using a classification algorithm, and one of them could be decision tree. Of course, there are more powerful or better algorithms available nowadays, but that's one fundamental algorithm that one can use in classifying data into different groups. So let's understand how is this classification performed using measuring distance, and that's a very simple way of doing it. So if I were to give you the few observations, so how do we classify? Well, the common sense would be, okay, find the distance between these points, and the nearby points are of one category. Here also these are nearby points, so that's of another category. So that's very common sense. Well, that's exactly the way even classification happens in. So of course there are variation of it. That means it is going to be more complicated, but the simplest way would be pretty much the same that we have done here. So classes could be represented by centroids, or what we call it as central value, or medoid, which when you sort of represents a particular group, which is sort of a representative in nature, or individual points. Okay, we'll take the algorithm the k nearest neighbor to understand. So k nearest neighbor is just one algorithm which is also used for classification purpose. Okay, so here is the data. We have got training set that include classes. So the idea is to examine k items near items to be classified, and the k could be 2, it could be 3, 4, and any number. You have the flexibility of choosing what is k. So all you need to do is that find a k and just group as many number of data points around a particular data point depending on the value of k. I will take an example to understand that better. New item placed in class with the most number of closed items. Okay, so that's the idea, having most number of closed item within a group, and which are very close by is the idea. So here is an example. So the k is 3 in this case. Okay, so for this point, okay, the particular point, what are the closest point near to the point? Okay, this one, and this one. So you take them and consider them as just one group. Okay, and if you increase k equal to 4, probably this point is going to be in the group. Okay, so that's one way of doing it. So how did you do it? We did by you calculating the distance, okay, or the Euclidean distance. Euclidean distance is just measuring the distance between 2 points, x and y, using the Euclidean formula. It's easy, right? You might have studied in high school how to calculate the distance between 2 points using Euclidean algorithms. Classification techniques available in the market for variety of uses are not just decision tree. There are of course many decision tree models that are available. Simple decision tree, multiple ones, which is also known as random forest. We will not get into the details of such algorithms. We'll just limit ourselves to the decision tree algorithm. Okay, there are rule based method, there are memory based reasoning methods, there are neural networks, Bayesian belief network, the support vector machines, there is more regression techniques, statistical techniques like logistic regression. So these are some of the very or maybe a linear discriminant analysis. So these are some of the classification techniques that people use in classifying data into different groups and subgroups. Well, our focus here in this case is decision tree. So here is an example of decision tree. Okay, and we'll see how a decision tree looks like. Where is we have got classes and we have got attributes. Okay, we have got attribute could be categorical or continuous. Okay, categorical data could take few values, repetitive values, and continuous could be purely continuous, that could lie any value between two set of values. So here is the case. We have got someone cheating you based on the taxable income, based on his marital status, and based on whether you will get refund or not. So based on these three attributes, you should be able to predict if someone is going to cheat you or not. Okay, and this is a given data. Okay, this is the given data, or we call that as a training data. So using training data, we would train a decision tree algorithm which would be able to find, given these three information, refund status, marital status, taxable income, whether one would be cheating you or not. Okay, so this looks like this. It starts with a refund. If somebody is refunding you, then it's not going to cheat you. So it's a straightforward case. No, he's not going to cheat you. If it doesn't refund, then there are many sub nodes to it. If it doesn't refund, then you need to look at what is his marital status. If he is married, then he is definitely not going to cheat you again. Okay, so if he's refund, he doesn't refund and he is still married, he is not going to cheat you. He refunds, he also not going to cheat you. The only case left is if he is single or divorced, then there is also a probability that he probably is going to cheat you, but only when it depends on the income. Okay, the taxable income. If the taxable income is greater than 80K, $80,000, then he is not going to cheat you. But if that's not the case, then he is going to, sorry, I said wrong. If the taxable income is greater than 80K, then he's going to cheat you. Otherwise, he's not going to cheat you. So if the given condition is, if someone is case that refund, he is not going to refund. He is married and he has an income of 60K. Okay, so what is going to be his status, whether he's going to cheat or not? Okay, so how do we look at it? We just look at the decision tree. Refund, no, so we are here, right? We are not here because this is yes, if only married. Okay, marital status. So we go straight away here. So we don't have to look into what the income status is. We're very sure that he's not going to cheat because that's where the decision says that he's not going to cheat. So that's the way. Had it been not married, so you go to this node and you see his taxable income. His taxable income is less than 80k, so he's not going to cheat. That's the way you decide the class of a new data. Another examples, there could be more than one tree that fits the same data. Okay, it need not be just so the tree could be totally different. Okay, and this is one such case which is slightly different from the one that we had seen. All right, so as we have seen, it's a very simple way of doing it. We have given a training data set that will be used to train an algorithm. So the algorithm here is decision tree. Find a model, apply that model, test data or new data to find out the class. Okay, so imagine this is a cheating example that we saw last time. So here will be asked, okay, what is going to be the class for someone with this? Well, this is a different example, but let's assume that's the one we are looking at here. It could be yes, it could be no, based on the model. Of course, you look at the model, get into the details of the decision tree and find out what this is going to be. So you apply the model to test data and find out what the case is. So here is an example. This is a test data. Refund status is no, marital status is married, taxable income is 80k. What is going to get at? Okay, refund status is no, so we are here. Marital status is married, so we are here, right? So it's straight away no, right? You don't even have to look into what is taxable income is. So cheat is no. So that's the final answer for us, that is not going to cheat. So we are now able to categorize this individual as somebody who is not going to cheat. So that's the idea here. Change the status, it is going to be different. So it's just how we did last while. Okay, I'll skip these steps because we have explained this, right? So you go step by step. You are here when you see refund is equal no. Then we go to the next one, married. So you are already here. So then you're here, you're already no, and then you assign no here. So how do you come up with this tree? Now we just saw some sort of this way, right? So how do you know which one to be here, which one to be next, how many splits are to be there, right? How do you know that 80k will be the split, somebody with less than 80k and somebody with greater than equal to 80k? Okay, how do you know all these things? That's the idea. So now we learned what decision tree is, how is it being used in real examples or real world, but we just need to know the theory behind it, or how do we come up with such a tree. There are several algorithms used. What's Hunt's algorithms, CART, and there are more also. I'm not aware of these two, but yeah, the famous one is of course the CART algorithm, which is known as the classification and regression tree. Classification and regression tree is basically used for classifying such data. Okay, so how do we come up with this tree? Split the records based on the attribute test that optimizes certain criteria. Now you do the classification in such a way that there is some criteria which is optimized. That means it is either minimized or either maximized. Okay, if I've seen what is a least square, if you are familiar with least square regression model, you might have found out a minimization of cost function, right? Minimization of cost function. So decision tree also takes care of that minimization of some sort of a cost function. So the criteria we are talking about is not just a cost function. So the splitting will happen in such a way that there is this cost function is optimized, it is minimized. So the issues of course that determine how to split the record, how to specify the attribute test conditions, under what condition the splitting is happening, how to determine the best split, how many number of splits are to be there, and the most important thing, when do you stop, or when are you going to stop? Okay, you cannot simply go on with splitting, you have to stop somewhere, right? And that's also very important. So we'll see how do we do that. So the first thing we'll see is how to specify the attribute test condition. So the test condition will depend what kind of attribute we're looking at. Remember what attribute we're looking at, we'll take that same condition, right? Somebody is going to cheat or not. So it depends on income, it depends on whether he is married or not. Okay, so married, whether someone is married is a classification variable, right? So it's a categorical variable, right? It's categorical. Whereas income is a continuous. Income is continuous variable, whereas married is a categorical variable. So specifying test condition depends what kind of attribute you are dealing with. It could be nominal, it could be ordinal, it could be continuous. The difference between nominal and ordinal is that they are both categorical, except the fact that nominal cases you cannot order them in some sort of order, whereas in ordinal case you can actually order, like small, medium, and large, like they can be ordered. So that's ordinal. In nominal, it could be different colors. It could be green, it could be blue or red. So you cannot class order green, blue or red. So that's nominal. And continuous, of course, is just a continuous value. So that's different from nominal and ordinal. It also depends on the number of splits you're going to have. That could be two-way splits. That could be multi-way split. That means you can actually split in two ways, and it could also be in multiple ways. So we'll see splitting based on nominal attribute. So this is a multi-way case where there are many partitions for a distinct value. So for instance, the example could be car type. It could be a family car, it could be a sports car, it could be a luxury car. So your criteria could depend on what kind of categories that you are having. Okay, so for instance, in the case of cheat, okay, you are dealing with someone cheating, right? And marital status could be single, divorce, and then married, right? We can actually combine these two also, because they pretty much represent same type. Depends, you can actually have separate ones or combined together, single and divorce. So that's one way of splitting the nominal attributes. So binary split would be divide values into two subsets, but we can have multiple as well. For instance, here in this case we have seen in the example that we showed in a few slides prior to this, we showed that single and divorce have been combined, and we have found that that's the optimal way of splitting the data into just two types: single divorce and married. Not single divorce married. That means there are not three splits; there are only two splits in this case. It depends how many splits you want to have, and we'll call that as optimal splits. So that's also one thing you need to learn, or you need to understand, that how do we decide how many splits are to be do we going to have are we going to have. So here we have seen that sports and luxury cars, we just keep it one, and then family just one. But how do we come to know that this is a good one, or this is a proper way of doing it? Okay, it could be family or luxury of one type and sports of another type. So that we'll get to know only after looking the training data. Okay, so we want to optimize a matrix or a value, and based on that we'll do this division. So the idea is we'll just go with the split. We'll go with the split that maximize the division of our end variable or the class variable that we have seen. So the class variable in the case is cheat. So any classification that is more accurately able to give as the classification of someone is going to cheat, someone is not going to cheat, will that consider that classification to be the optimal one. Splitting could happen with the ordinal attributes also. Ordinal attributes, as I've said, it could be somebody who can be ordered, small, medium, and large. And similarly, the way we have seen in the nominal case, we can also combine some of the splits and find out what is the optimal one. How do we know? Again, we'll go with some sort of a cost function. We'll ensure that the split which is helping us classifying the data in a better way is the best split, and we'll find that out using some sort of an algorithm. Then splitting based on continuous. With nominal or ordinal, or in category case, it's easier. Whereas in continuous case, how do you know that? How do you sort of use continuous variable to classify? Remember the example that we had taken. We had taken 80K as the splitting criteria. Someone with income after tax less than 80K and someone with more than 80K. How do you know that 80K? How do you know that this split value, or the value that splits these two groups? How do you come up with such a value or such a threshold? There are different ways of dealing with the continuous data. Discretization is the way to form an ordinal category attribute. That means income group can be lower income group, middle income group, higher income group. That's one way of doing it. Lower income group, middle income group, and then high income group. Okay, so based on somebody's income, you can categorize them into three types: lower class, middle class, higher class. You can have more classes also: lower middle class, lower class, middle class, higher middle class, and higher class. Okay, so you can have as many numbers you can, but just take the one that maximizes your classification chances. You could also do bucketing, something like income between $10,000 to $20,000, 20 to 40, 40 to 60, 60 to 80, 80 to 100, 100 and above. Okay, so that is some sort of a bucketing. So you have just 6 classes of income groups, and just see if that actually helps. You can combine, make it just 4 classes or 3 classes, as many classes, which helps you classifying your data, that is whether somebody is going to cheat or not, in the best possible way. That's the way. Binary decision is taken based on a threshold value, like the way we have seen in the example. We have taken 80K as the threshold value. Someone with less than 80K and other criteria is not going to cheat. Somebody with greater than 80K and other criteria is included is going to cheat. So that's the idea here. How to come up with this 80K, this threshold value, using some sort of a split criteria or some sort of algorithm, and we'll see that how we come up with this. So taxable income 80K, yes or no, that's binary split. Multiple split, we have already explained. It could be the intervals, right? 10 to 50, 25, 25 to 50, 50 to 80, and greater than 80, less than 10. There could be 5 different categories. That's the way you can actually do the splitting. But it's not up to you to decide. You have to go with the splitting criteria that actually optimizes the classification. The idea here is to get the correct prediction, right? If somebody is going to cheat, your model should be able to provide the information before, given his income, given his marital status and refund status, right? So that's the idea. So split will happen based on this end result, or based on this objective. Okay, so how to determine the best split? We have seen how to do splits, but how to determine the best split? The best split, finding out the best split, is done before, like this. We'll take an example. So here is the split. We have got 10 records with classes as 0. We have got another 10 records with classes as 1. So we have 0, 0, 0, such as 10 classes. 1, 1, 1, another 10 places. And we have also got the attributes associated. One is owning car type, and then student ID. There are three different attributes given for this classification or groupings, and all you need to know whether it belongs to class 0 or class 1. So given somebody's car ownership, given somebody car type, given somebody's ID, student ID, we need to know if is 1 or 0, right? We'll use a decision tree for that. So which test condition is the best? Car ownership, car type, or student type? Now let's see the distribution of this 10 observation, 10, 10 observation, 20 observation, right? We have 10 zeros and 10 1, 20 observation within this category, right? So car ownership, yes and no. We can see that zeros in yes case is 6 and no case is 4, and no it's 4 and 6. Okay, so 4 people have cars and yes, 4 people have cars, 6 people don't have car. Am I right? No. Car ownership, yes, 6 people are 0 and 4 of them are 1. So that's 6 is to 4. Okay. If this is car type, you can see if it is family, then 1 and 3, sports, then 8 and 0, luxury, then 1 and 7. More distribution, right? More 6 and 4, the difference is very close, right? The difference is only 2. Here in this case, it's 2, it's 8, difference is 6. So the idea is that there should be maximum difference, maximum split, or between the categories. Okay, here student ID, there are 20 different student ID. You can see it's always 0, 1, 0, 0, 1, 1, 0, 0. That means the difference is always 1, 1, 1. That's not a good criteria. It has to be more than 1, right? You simply cannot have just a 1 and 0 and take that as a. So this is a bad split, bad attribute used for splitting. This is much better. Car type is much better. Car ownership is also okay, but not as good as car type, because here you can see the difference between the percentage of distribution is higher, and that should be the idea. So remember, we are talking about the cost function optimization. So here is the case. So the optimization happens in such a way that the difference in percentage of distribution should be high. Here it is 1 and 3, so difference is 2. 8 and 0, difference is 8. So that means there are 8 zeros and just 0, 1. So difference is more in this case, and that's a good thing. Here it's also same. That's the idea. How to determine the best split? Okay. So the idea is the nodes with homogeneous class distribution are preferred. So all we need to know is the measure of node impurity. Okay. So that should be maximum distance between different nodes and minimum distance within the node. Okay. So within the node there should be minimum distance, whereas between the node there should be maximum distance. Okay. So we need to compute the node impurity to be able to find that. So here is the case. It's a non-homogeneous case. So see, zeros is 5, 1 is 5. It's not a good classification because the difference is 5 minus 5 is just 0. So we need to maximize this. Here in this is a good example. It's a homogeneous one where we have got number of zeros is 9, number of 1 is just 1. So the difference is 9 minus 1 is 8. So that's good. That's better. That means the difference is the difference is nothing but this distance. It has to be more and more. That's a better classification. So how do we measure the node impurity? So there are different matrices that is being used. One is Gini index, the other one is entropy. The third one and a very popular one is the misclassification error. So how do we find the best split? Alright, so here is the one. The classification for 0, 1, 1 a priori, let's call that as n00, n01. And when with the attribute 1 and the different nodes, you got some sort of a number, right? We have seen that in the previous example. Here also we got some sort of a number, right? So the idea is, we call that as M0, we call that as M1, M2, M3 and M4. And you combine this and you find M12, M34. The idea or the gain you get is what is the difference between M0 minus M12 and M0 minus M34. If you take the example in few slides before, it's very evident. Well, what is your M0? 10 records and 10 records. That means your M0 is just 1, right? Because they're the same numbers. Here if you calculate that, the difference is very simple, right? It is 2. Here is also 2, right? So it is okay, let me see. Okay, so this is some percentage of the total values, okay, and this is also some percent of the total value. Okay, this is 1 minus, it's just 2 by 10 plus 2 by 10. Okay, so this would give us some sort of a number. This would be 6 by 10. If you compute this one, this would obviously be higher. Okay, yeah. So the idea is that the distribution should be more uneven in nature. Here it is more even, here it is less even, and that's the way you find out what is the best possible split. So we find the unevenness, okay, and combine them and see initial distribution was this. After splitting, this is the distribution. How is the difference? Okay, whether there is a great difference or not. If attribute A is find out a great difference between two different splits, attribute B is find out some sort of a difference. Which one is a bigger difference? See that and find out that's going to be the case. So how to compute impurity or Gini index? Gini index, as I've said, is one of the index that is used. Remember, impurity that we're talking about is nothing but exactly this one. Okay, so this is just a gain. There are different versions of it. One version is Gini. We calculate in this particular way. I'm not getting into the details of calculation Gini, but I'll just briefly give you the idea what Gini is. And Gini is very popular index to find out the income distribution, right? You might have heard about income distribution. The idea is that with Gini index, we'll know whether there is a proper classification, right, or not. So it's 1 minus summation of p j given t whole square. So that's like the relative frequency of class j at node t. Okay, and you just square that and sum it across all classes, and subtract it from 1, and you get the Gini index. And we'll see how to calculate a Gini index. So here is an example. We have got C1 and C2. C1 is 0 and C2 is 6. So these are two nodes. Gini in this case is considered to be 0. Okay, and that's the best classification because the difference is more, right? 6 minus 0 is 6, so difference is more, so Gini is also more. Here it difference is less, 5 1, so difference is 4, so Gini is more now. Okay, here the difference is even less, 4 minus 2 is just 2, so Gini increases. And here the difference is nothing, like 3 minus 3 is 0, so Gini is 4. So when Gini is 0.5, that means there is no difference between the classes, and that we do not want. We rather want this one because that is maximum difference, there is maximum classification. So somebody with Gini close to 0 is a preferred one over Gini close to 5. So Gini should be very close to 0 for a good classifier. And if Gini is very close to 0.5, then it's not a good classifier. So an example of computation of Gini, we have got the formula, so you can use it. Okay, here is the 0, 1, 1 case. So calculate probability of C1, because there are different probability for different classes with at a particular node. So this is node 1. So 0 divided by 6 is just 0, and probability of C2 is 6 by 6, because total is 6 by the way. Okay, 6 by 6 plus 0, right? So that's 1, right? 6 by 6 is 1. So how you calculate Gini is nothing but 1 minus, probability of C1 square, and that's, and then probability of C2 square, that's nothing but 0. Okay, that's a very good Gini, right? Close to 0 is better. You come here, calculate similar way, is 1 by 6, then 5 by 6, and then 1 minus 1 by 6 square minus 1 by 5 by 6 square, and it comes out to 0.278. So you know how to calculate. The idea is to that something with a Gini close to 0 is the best one, or that should be a preferred one. Remember the attributes that we talked in the diagram? The attributes that has such, Gini closer to 0 or higher impurity will be chosen first, and then it goes downwards. So splitting based on Gini. So based on Gini values, you can actually split. It's used in all such cases. When a node P is split into K partitions, the quality of split is computed like this. So this is just another formula to calculate what is the quality of the split, and that's one criterion used to find out what should be the number of partitions. That should be K equal to 2, 3, 4, or more. Okay, normally it is always 2 or 3 or maximum 4, not many partitions you would come across. Binary attributes. So how do we compute a Gini index in this case? Okay, so I've seen already how to calculate Gini index, right? So we won't get into the details of how how to calculate it again. You can also calculate Gini index for categorical attributes. So we knew how to do it for continuous, but we can also do it for categorical cases. Okay, and there could be multi-way splits and two-way splits. I think in the case of car type, so that's the way you calculate a Gini index. Okay, so how do you do that? You calculate proportion and find it out. Okay, how do you do that? You find a proportion, right? I won't go into the details of it, but yeah. So all you need to know from this slide is that even for categorical attributes, you can use Gini index, and use that for splitting your data into different classes. All right. So here is the real example that we have seen. Taxable income greater than 80k. Yes or no? How do we come up with that 80? Remember, we had seen in that example, we can actually use Gini index to get into that. So how do you do that? So use binary decision based on one value. How do we come up with that one value? So we had one value is 80k. So the several choices are there. Like data, we have got 10 choices, and every choice is a potential candidate for a split or for a threshold. So why we go ahead with 80? Why not anything else? Okay, why not anything else? Any number between the smallest and the largest one could be a potential threshold. How do we come up with that? So each splitting value has a count matrix associated with. Class counts in each partition is so what is that value for which you get the best classification, and that we have found out to be 80. And using Gini index you can find it out. So for each V, that means for each threshold, and threshold by the way can be any number in this income group. For each V, scan the database to gather count matrix and compute its Gini index. Okay, and based on the Gini index, you find out where exactly your entropy is your impurity is maximized, or impurity is optimized, and take a decision on that. Okay, and we have found out that 80k is the cases where it is maximized. It's very computationally intensive because every number is just 10 number, but in real examples you will have thousands, 100, 10,000 millions numbers, and calculating for each number a threshold value as a potential threshold value is very difficult. It's very computationally intensive, and that's not a big deal now because computational power of machines now has gone up drastically in the modern world. Like Gini, you can also use what is known as entropy. The formula I just changed, but the computation is very similar, except the fact that the reason why we have another matrix other than Gini is because we need to deal with computational efficiency. Okay, so entropy is just another improvisation from Gini, where the computational power has now improved a bit, depending on the case, of course. So entropy is just another way of finding out a criteria. The computation is very similar to what we have seen, except the fact that the formula has changed now. Right? You can see the formula was different. We were subtracting from 1 minus, but it's now changed. Otherwise, the calculation is pretty much the same. All right. So you can calculate the information gain with different splits for different attributes using entropy. So that's the idea. So Gini, entropy are the matrices that you would calculate to find out the information gain for every attribute and how many splits are to be there for every attribute and which one is to be given preference. How do you know the first node and how do you go down to the tree? So that's the way you find out. You go ahead with finding out some sort of a splitting criteria. The third one we have seen is classification error, right? Apart from Gini and entropy, you can also use classification error. So classification error is also used like this. Classification error T is nothing but 1 minus maximum of probability of Pi by T. T is just the node and I is the number of classes, probability of happening of the class. So you use misclassification error by the node. Misclassification is very easy, right? Somebody said yes and prediction is yes, it's not an error, it's matching. If it is yes but the prediction is no, then this is misclassification. So you go by that that number of splits which minimizes misclassification. That's the idea. Again, that is similar to what we have seen in other two matrices. Okay. So here is an example. How do you calculate this? Okay. So the probability of C1 in this case 0 by 6 is 0. Probability of C2 is 6 by 6 1. So error is nothing but 1 minus maximum of 0 and 1. Maximum of 0 1 is 1. 1 minus 1 is 0. Same, right? Easy. Probability of C1 is 1 minus 6. C2 is 5 by 6. Maximum that of is 5 by 6. So 1 minus 5 by 6 is 1 by 6. Right? That's the way you calculate the misclassification error and yeah. So what we have learned so far is that Gini, entropy and misclassification error can be used in order to be able to find out attributes, number of classification and thresholds in a decision tree. And that's exactly what is needed, right? Remember the slides that we have seen in the beginning? We were interested in these three. How to specify attribute test condition, how to determine the best splits. Now these two you can find out through calculating these matrices and applying. Of course, nowadays you don't have to do all these things because the computer gives you. If you're using R, SAS or a MATLAB, you don't have to do all these things. You don't have to calculate Gini, entropy and misclassification. It calculates it for you. All you need to do is that give your target variable your class variable or target variable, and give attribute 1, attribute 2, attribute 3, all three, and it's going to give you the tree, final tree. You don't have to do all these calculations. So all that I have explained to you so far is for your understanding. Probably it's not the in very detailed way, but I've tried to ensure that to keep it as simple as possible, as novice as as I can, so that even someone beginner in machine learning or data mining should be able to understand what the heck is decision tree. So the final thing that we're interested in is determine when to stop. Now the tree can go on. It can go on and on. So how do you know? So where exactly is to be stopped? So we consider what is known as a stopping criteria for tree reduction. So stop expanding a node when all the records belongs to the same classes. Now you go on classifying, but if these two classes have same cheat percentage, 5% here, 5.5% here, number of percentage of cheat, okay, I'm taking the same example, cheating yes is 5% in this node and 5.5% this node. That is similar, right? That means this particular classification hasn't done much of a use. We can stop there. We probably stop below there also, but yeah, if you're a bit more serious about it, but you can stop here. So we'll just see that when exactly the classes down below in the decision tree do not have a lot of difference in the distribution. Stop expanding a node when all records have similar attribute values. Okay. So if you have only cheat here and only cheat here as well, no point, right? There should be difference. Otherwise, there is no point in doing another classification, right? So will you classify something which is already classified, right? You know that this is already classified. So there are two trees. You find crosses here. You also find clauses here. Is this classification? No. That means we should stop there. We should stop this particular node. You don't even have to go below. Okay. This is classification is useful when you have something like this. Or maybe just one. This is useful because they are all crosses, they are all zeros. But if they are all same, it's of no use. Right? So that's the idea. That's the way you terminate something. Again, this will all be done in the software itself. We are using R. We're going to give you the stopping criteria directly. You don't have to seriously go and look at the stopping criteria. It automatically does it for you. Okay, so what are the advantages? We have learned about the theory. Now we have learned what decision tree, what the applications of decision tree, and what the theory behind decision tree. So we have come to three things that we have learned, right? So we now go to the next thing. What is the advantage of using a decision tree? It's very inexpensive. Okay, it's easy algorithm actually. Okay, many of these classification algorithms, like neural network, like support vector machines, are not that easy to find out or to use. It's more expensive in terms of using computational times, and it's easy to find out. Even you can use Excel sheet. You can use Excel to come up with a decision tree algorithm. It's extremely fast classifying. So if you have a large data set and you want to quickly do something, so decision tree is a very good algorithm to use. And it's easy to interpret, right? Because you can actually visualize it very well. So it's easy to interpret. So if you are planning to explain this to a non-technical audience, you can actually use this and explain to them. So that's very good. Accuracy is comparable to other classification techniques for even a simple data set. That means the percentage of correct classification is also very good, although not very good. Probably something like neural network will do a better job in terms of classifying, but it is more expensive computationally, and also building the model itself and also explaining to people. If you compromise a bit on the classification and you more want to present into non-technical people and do it in a faster way, then decision tree is the algorithm to go about. Practical uses of classification. So there are a few things that you need to take into consideration while building a decision tree. You should understand whether the decision tree model is underfitting or overfitting. And these are technical jargons. These are jargons you need to understand. What is underfitting, overfitting? There are no difficult things. They are easy to understand. What if there are missing values in your dataset, in your training dataset? How does it affect your model? The cost of classification, how big the classification should be. Okay, so can you just have as many number of nodes in your data, or you can just have a simpler one? What is the cost of classification? You need to understand all this. So here's an example of underfitting and overfitting. So here is, you have got red points, the circular points and the triangular points. So ideally, so the square root of x1 square and x2 square, x1 is this one, x2 is this two, sorry, the y-axis is nothing but x2. So if this is lying between 0.5 and 1, then it is triangular. This is the one. Otherwise, okay, sorry. So if it is lying between 0.5 to 1, it is circular. So this is the case, these red points. And otherwise, if it is like less than 1 or greater than 0.5, the square root of x1 square, x2 square, then it is the triangular one. That's the criteria. That's the decision that you can use to classify. Okay. Now the overfit condition would be to train a model that is completely classifying. Okay. Now if you have something like this, so you completely classify this. Now if you use this model for new data, completely new data, you will underperform, because this model is only doing very good only on the training data. You have to fit something that is more generic, something that can be used even for new data. So how does people come up with this overfitting? When they use very complex model. So what is complex model in the case of decision tree? Using too many attributes. Too many attributes is bad. Using a very large tree, okay, very complex tree with more number of nodes, that's also not a good thing. If you use these two, then you may have a problem of overfitting. That means you are really good at predicting the training data set, but it will do bad job in predicting test data set. What is underfitting? Well, underfitting is case where you have very simple model. That means you have used only a very few attributes, one or two. That's not going to do the job. And only few nodes, or very simple tree, there are only 2 nodes. That's the way. Okay, or maybe 4, just 4, just not just one branch, just few more branches, and that's not going to do the job. You have to optimal in nature. The simple models will not do the good job. That will be underfit. That means it is going to do a bad job for your new data. So the trade-off between underfitting and overfitting, because you have to lie somewhere in between, overfitting and underfitting. You cannot underfit, which is at the lower side, overfit at the higher side. You have to somewhere in between. So the trade-off is here. You have error percentage, you have number of nodes. Number of nodes is nothing but, we call that, this is a node, right? This is node. You go below and go. The more nodes you have, the more complex the model is. You cannot have a very simple model with fewer nodes. You cannot have too many nodes and have a very complex model. So you have to be somewhere between. The trade-off is like this. If you have a very simple model with very less number of nodes, look at this number, less than 30, then you will have very high percentage of error. Okay, very high percentage of error. both in training data and test data. By the way, training data is something that we know for sure, something that we are using for building model. But test data is something that you're using completely new. It's completely new data. So we haven't seen the class or the target variable, and that matters to us more than training, right? So we have both high error in this case, and we increase that. Okay, we went right, we increase that to 50, 100, more and more. Now you can see that the training error is coming down. Now you might think it's a good thing. The more you increase, the lesser error you will find. But we don't care the training error about, we care only about the test error. Now we want less error, right? So we might think that we should have 250 number of nodes because the training error is less. No, we have to look at the test error. You can see with number of nodes, with increase in nodes, the test error is actually going down, but at one point is again going up. That means we need to find what is the optimal. So optimal is here, this line, right? That's where uses the minimum test error, right? So you need to remember one thing. You need to find the number of nodes at which the test error is minimum. So test error is minimum at 170 or 80, that place, right? So always minimize test error. So this is the error cost function we have to build. The number of nodes denoted by p depends on how the test error is, what is the test error, and whether it's minimum or not. Overfitting could be due to noise sometimes, or what we call outliers, right? If you have outliers in a data, outliers are data which are completely different from other data. It could actually overfit. Like in this case, ideally the data should be this, the classification should be this. But now with an outlier here, what you have done is it is going here and then coming down, going here and coming down. That's a perfect classification, but it's not going to work in a new data. So a noise point outlier should be removed from your data. This is a basic modeling practice. Outliers should always be removed from your data before using. Otherwise, your decision tree model is not going to do a good job. Insufficient data sets. Now you know the more information you have, the better the model will be. More info is better. Now this is one thing you need to always understand. More information is always good. Less information, you are building a decision tree model with 10 observation or 20 observation. That's not a good data set to be used for building model. So that will going to be a problem. So make sure that you have more number of observation for classification. Otherwise, it's going to do a very poor job. Okay, so some notes. Overfitting results in decision tree that are more complex than necessary. Complex models are not good. Okay, training error no longer provides good estimate of how well the tree will perform on previous data. It is always the test error. Again, I would say, I've said this, training error doesn't matter. What matter is the error and test data, test error. Okay, so we build the model on training. We test it in a totally new data, right? New data. And that's where if the error rate is less, you are sure that it's going to do a good job. So the jargon is called Occam's razor. That means you should use a simpler model. Given two models of similar generalization error, the one that would be preferred should be simple over complex model. So everywhere a simple model should be used if it is doing a good job. So for complex model, there is a greater chance that it was fitted accidentally. That means it accidentally does a good job, but it's not going to do a good job in future. So complex models should not be used or should be avoided. Okay. The last thing we'll see is the cost of using a model. I won't get to the details of this. It's not very useful, but yeah, sometimes it is useful and you need to understand that. So what is known as minimum description length, or MDL? That means how big your model should be. Okay, so the three costs: cost of model and data is equal to cost of data given the model plus cost of the model. The cost is the number of bits needed for encoding search for the least costly model. That means the model should be least costly. Okay, so how do we define the cost? Cost of data given model is the misclassification error. So that stands for the cost of data given model. And cost of model is nothing but the number of children plus splitting conditions encoding. That means how many split, how many branches is happening here. So all that will be taken into consideration, and you calculate this matrix and find out with the least cost. All that is being taken care of by the software nowadays. You don't have to worry, but sometimes you have to do manual decisions to cut down on some of the branches which are not necessary. How to address overfitting? It's very easy, and sometimes not so easy. The reason it is easy because there are certain things which are very trivial and you need to take care of them very easily. You should not use too many attributes. Too many attributes is bad. Too big decision tree is bad. Too many nodes in a decision tree is bad, right? Sometimes you have to use stopping conditions very early, and there are some thumb rules. Stop if all instances belong to the same class. Stop if all attribute values are the same. So these are stopping conditions. You can actually use more restrictive conditions to stop the node without going to the more and more node. Right? You can actually go to more and more. Somewhere you have to stop. Right? How to decide? How to decide what is the best one? Well, we have seen the decision, but sometimes it can be much bigger than what we have expected. Sometimes we have to take a manual decision to shorten it instead of going ahead with the automated algorithm given by softwares using R or SAS or MATLAB. Okay. So that's the way you deal with overfitting. Handling missing values. Missing value is going to be a problem in all models that you learn in your life. It's not a good thing. If you are able to remove missing values from data, that's the best way to deal with. If you want to do the imputation, you want to replace with some values, that's the next best thing to do. So it affects greatly. It affects while calculating impurity calculations, calculating Gini and entropy. You'll have problem calculating such things. So you need to take care of missing value really well before building model. For that matter, any statistical or machine learning model or data mining model that you are going to build in life, all the times you will have to deal with missing value very carefully, otherwise it's going to create problems. So that's pretty much what we have seen, or what we understood about decision tree. Of course, there is another part. How do we build a decision tree within R or using MATLAB? In our next video, we will understand how to build a decision tree using R. So we'll take a data set, use a decision tree, and apply that in a real example to do that. We'll see that see you in that next video, next session, where we'll show that to you. Thanks for watching. Please subscribe to us. This is a channel we have specifically for people who are willing to learn data science, machine learning, or any of these data science algorithms. And it's specifically targeted for beginners. So please subscribe to us. Please tell your friends to subscribe, and please comment and share with all your friends. Thank you so much. Thanks for watching.